An ellipse is the locus of all points in a plane such that the sum of the distance from the two given fixed points in the plane called the foci is constant. This is an ellipse. B and B prime are the vertex of an ellipse. F prime and F are the foci of an ellipse. C is the center of an ellipse, which is the intersection of the major and minor axis. The distance from B to B prime is the major axis. The distance from B to B prime is the minor axis. The distance from A to A prime is the lattice rectangle, which is perpendicular to the major axis. These are some terminology of an ellipse. F and F prime are foci. B and B prime and B and B prime are called the vertex of the ellipse. B prime and B is called the major axis, and B prime is called the minor axis. C, which is the intersection point of the major and the minor axis, called the center of the ellipse. CV and CV prime are called the semi-major axis, and CV and CV prime are called the semi-minor axis. A chord AA, which is perpendicular to the major axis at F, is called the lattice rectangle of the ellipse. The distance from the center to the focus is denoted by C. The length of the semi-major axis is denoted by A, and the length of the semi-minor axis is denoted by B. The equicentricity of an ellipse, usually denoted by E, is the ratio of the distance between the two foci to the length of the major axis. That is, the distance between the two foci, the length of the major axis, which is E equals C over A, which is A is a number between 0 and 1. Note that V and F prime equals V and F, and VF plus VF prime equals VB prime and equals to A, according to the definition. P is any point on the ellipse. P is any point on the ellipse. You have PF plus PF prime equals to A. Since P is on the ellipse, we also have that BF plus BF prime, which is to A, but BF equals BF prime. This implies BF equals A. Using the Pythagoras theorem for right angle triangle BCF, you get CB squared plus CF squared equals BF squared, but CB is B and CF C and BF A. Therefore, ABC have the relations B squared plus C squared equals A squared. An ellipse is formed by the intersection of a plane and a cone at some angle theta. These are the picture. The distance from the center to focus is C. The distance from the center to major axis is B. The distance from the focus to vertex is called A. And the total distance of the major axis A plus A, which equals to A. This picture is all about the terminology of an ellipse. The distance from the center, which is the intersection of the major and its minor axis, to the focus equals C. This is the distance from the center to the focus equals C. And also the distance from the center to F2 equals C. And the distance from the center to V2 equals C, and the distance from the focus from the center to V1 equals C. This is the length of the semi-major axis. The total distance of the vertex from V1 to V2 equals the total distance of the vertex equals to A. Here is the minor axis. The distance from the center to B, which is the semi-minor axis, the length of semi-minor axis equals B, which is the distance from the center to B, and the distance from the center to the extreme end of the semi-minor axis equals B. Here is the distance from focus to V1, which is the distance from the focus to V1 equals A minus C. The distance from V1 to F2, which is the distance from V1 to F2 equals A minus C plus 2C, and the distance from F1 to F2 equals 2C. Therefore, the total distance from V1 to F1 plus from V1 to the total distance from V1 to F1, which is V1 F1 plus from V1 to F2, which is V1 F2 equals to A, which is the length of the major axis. Assuming that V1 is on an ellipse, the distance from V1 to F1 plus the distance from V1 to F2 equals to A. The conclusion is the distance from any point on an ellipse to F1 plus the distance from that point to F2 equals to A, which is P F1 plus P F2 equals to A. A is the length of the major axis. F1 and F2 are the foci of an ellipse, and P is any point on an ellipse. So P1 F1 plus P2 F2 equals the total length of the major axis. Here is the distance from F2 to B, which is P squared plus C squared equals under radical square. From the figure above, the point V1 is on an ellipse. The distance from V1 to F1, as we already mentioned, A minus C. The distance from V1 to F2 equals A minus C plus 2C. The sum of the distance from F1 to F1 and F2 equals A minus C plus 2C equals to A. So we take a point Px on the ellipse such that P F1 plus P F2 equals to A. Here is using the distance formula. The distance from P to F2 equals the distance from P to F2 equals this equation, and the distance from P to F1 equals this equation. When you simplify, this equation gives x squared over a squared plus y squared over b squared, which equals 1. This is the equation of an ellipse when the major axis lies on the x-axis and the minor axis in the y-axis. Example. what are the value of a and b in the equation of an ellipse 16x squared plus 25y squared, which is equal to 1600. Solution. Divide both sides by 1600 and give us x squared over 100 plus y squared over 64, which equals 1. Now, compare this equation with equation of an ellipse and the major axis lies on the x-axis. Here is the value of a squared equals 100 and the value is 10. The value of b squared equals 64 and the value of b equals 8. B squared equals. So the length of the major axis is twice a, which is 20, and the length of the minor axis is twice b, which is 16. This is another example. Find the length of the major and the minor axis of the ellipse x squared over 25 plus y squared over 16, which equals 1. Solution. The equation of an ellipse is x squared over 25 plus y squared over 16, which equals 1. So compare this equation with the equation of an ellipse. In the major axis lies in the x-axis and the minor axis in the y-axis. Comparing this equation, a squared equals 25, which implies a is 5, and b squared equals 16. B squared equals 16, which implies b equals 4. So the length of the major axis is twice a, which is 10, and the length of the minor axis is twice b, which is 8. Question number 3. Find the equation of ellipse having the major axis along the x-axis and passing through the point minus 3, 1 and 2 minus 2. Solution. This ellipse passing through the point minus 3, 1 and 2 minus 2. Substitute minus 3 into x and 1 into y. And give us the equation, which is gives the equation which minus 3 squared is 9 over a squared plus 1 square is 1 over b squared, which equals 1. So when you substitute minus 3 1 into this equation, gives 9 over a squared plus 1 over b squared, which equals 1. And again substitute 2 into the x and minus 2 into the y, and it gives this equation. Substitute 2 into x gives 4 over a squared. Substitute minus 2 into y gives 4 over b squared. So 4 over a squared plus 4 over b squared, which equals 1. Solving this equation simultaneously using a simultaneous equation. When you solve, the value of a squared equals 32 over 25, and the value of b squared equals 32 over 5. Solving this equation simultaneously, the value of a squared equals 32 over 3, which is, and the value of b squared equals 32 over 5. So the equation of the ellipse is 3x squared plus 5y squared, which equals 32. Question number 4. The length of the semi-major and the semi-minor axis of an ellipse is 5 inch and 3 inch respectively. Find its equicentricity and the length of the lattice rectum. Solution. To find the equicentricity and the length of the lattice rectum of an ellipse given. A which equals 5 and B which equals 3. Now applying the ellipse formula for equicentricity equals under radical 1 minus b squared or a squared, and substitute the value of p, and a gives 0.8. Now applying the ellipse formula, the length of the lattice rectum, which equals 2 times b squared over a, that gives 3.6 centimeter. The equicentricity and the length of the lattice rectum are 0.8 and 3.6.